Hello everyone, my name is Fan Yang. I'm the technical marketing engineer working on the CSR1000V. Today I'm going to talk about how to use CSR1000V deployed in the public cloud to enable your IP mobility, which I have seen a lot of customers asking for it. If you have any questions, and put your comments under the video and I will reply to them. So let's jump into it. So the typical user scenario is like this. I want to stretch my subnet across public cloud and data center. Looking at the diagram below, you have your green subnet, which is 10.0.1.0, which is being used by your web application team, and also the database team. And you have another set of subnet, which is 20 subnet, and it's used by the management team to do some management access, logging, whatever. And the web team said, okay, now I have this public cloud, I want to move some of my application into the public cloud, but still have my database running on the data center because I don't want to move those critical sensitive data into the cloud yet. So the requirement comes to you as a network admin or network architect. How can I stretch the same subnet across data center and the AWS VPC? Without using any other technology today, you cannot, because if you create a VPC with the same setup log or the same IP range as your data center, they cannot talk to each other unless you enable sort of the netting. But if they are in the same subnet, and it happens if the application hard-coded the IP address of that database, so the net will not work there. So that's one of the requirements. By moving application to the cloud, but not changing the IP address, and they still need to be presented in the same subnet environment to talk to each other. So that's one challenge. The second challenge is you still have those subnets which they don't overlap. Let's see your management subnet in this case, and they still need to continuously talk to the web server even if they are moving to the cloud. So how does your on-premise equipment know now that web server sits in the cloud, I need to redirect the traffic to the cloud? So those two challenges becomes more often and more often since large enterprise customers are moving their application into the cloud. So from a network admin perspective, we need to solve this problem. So let's see what are options. And before we're talking about the solution or the technology Cisco provide, one of the other challenges that has in the public cloud is there's no layer 2 capability. In terms of there's no multicast, there's no broadcast. Which means if you run a server in the AWS VPC or in any of the cloud like Azure VNet or Google Cloud Platform VPC, the VM will never receive an ARP request to itself. It is because the cloud infrastructure is hijacking the ARP request, and they will respond to the ARP request. So as a VM, from a VM standpoint, it doesn't receive the ARP request. And also, it will never receive a gracious ARP. And the gracious ARP is often being used in a lot of protocols like HSRP, like when you want to refresh the MAC table of the client VM. Typically, the router will send out the gracious ARP, but it doesn't work in the cloud. So that's why we have a solution for the HA, which is cloud native HA, which is not covered in this presentation, but it's in one of my videos. So HSRP doesn't work, and OTV doesn't work either. So a lot of layer 2 capability protocol doesn't work. So let's see what are the options we have. So LISP is a layer 3 protocol, so it doesn't require a specific layer 2 capability, and it will help you to enable the IP mobility function. So in order to use LISP on CSR in the public cloud, you need to have 16.9.1 release, which is just released a couple days before. And AWS is the first cloud provider we support, and we are working to support Azure and Google. So you need to deploy a CSR in the AWS VPC, which is on the left side, you have that blue router, which is CSR, and you have your ASR, which is running on the data center side, which is on the right side. And they need to talk to each other based on IPsec tunnel. If you have another set of transport, let's say if you have direct connect, then you might not need the IPsec tunnel. But in this case, we are using internet, so you need to use an IPsec tunnel. And CSR is configured as the XTR, and ASR is configured as a proxy XTR. If you are familiar with LISP concept, then you understand what does XTR mean and PXTR mean. So in a nutshell, XTR is used when there's only LISP subnet connected to the router, so that's a XTR. And PXTR is proxy XTR, so it also handles the LISP subnet and non-LISP subnets. And in this case, the ASR, which is the data center side, you need to handle the request coming from the LISP subnet, which is a 10.0.1.0 subnet, and also the non-LISP subnet, which is the blue subnet, the 20.0.2.0 subnet. Dynamic host detection is enabled on the LAN side, LAN-facing interface. So on the CSR, you have gigabit 1, which is connected to the internet, which is the AWS Internet Gateway. And you have gigabit 2, which is connected to your web server. So you have a private subnet. So that's what you need to enable on the private-facing interface. And on the ASR side, you have gigabit 2, you have gigabit 3, but only gigabit 2 is the one that's facing the LISP subnet. So that's the interface you need to enable dynamic host detection. You don't have to do it for gigabit 3 because it connects to a non-LISP subnet. And due to the AWS VPC layer 2 multicast broadcast restraints we talked about in previous slides, there's one important step you need to do. Because the AWS side, you cannot receive a gracious ARP, right? You don't receive the ARP request. So how does web server know on the left side to know the database server's MAC address? Well, how does the AWS know for that IP address, I need to send to the CSR, so the CSR can send the packet to the right side. So you need to configure the IP address of your data center side server, which is in the same subnet, to be present on the CSR's interface on AWS console, not in iOS XE. Yeah, it's a little bit confusing, right? So let's see what you need to do in the next page. So here's what you need to do. You need to go to the Elastic Network interface and configure secondary IP on that Elastic Network interface. And that ENI is the private-facing ENI. So on the right side, if we go back to the previous here, the database server is 1.100. So what you need to do is you need to configure this 1.100 IP address on the AWS console for that ENI as secondary IP. That's why you have this 100.1, this 10.0.1.100 IP address presented on the ENI console. But this IP address doesn't need to be configured on the CSR in iOS XE. So in the CSR configuration, if you do a show run, you don't see this IP address configured on the gigabit 2. The reason for that is you don't want the CSR to respond to this IP address request, right? Because actually this is the IP sits on the data center side. And you might have a question, okay, then I'm gonna run into a scale problem or a scale. I need to take the scale into consideration. Yes, you are. And AWS gave this table, and you can find this on the public information. So how many secondary IP you can configure under ENI is dependent on the instance types. So for example, if you are running T2 medium, you can only have 3 network interface, but each interface can have up to 6 IP address. Then you're gonna have up to 18 IP address as secondary, which you can configure. So which means on the left side, you can have maximum up to 18 hosts. So you can do the calculation yourself to identify how many subnet you can configure. or how many hosts you can configure to use in this solution. So this is a very simple demo I have, or I want to show you how it works. On the left side, as we talked about it in the previous discussion, you have your AWS environment, your VPC. On the right side, you have your data center. So let's take a look at the left side first, because it's easily set up. In this VPC, you have a web server, which IP address is 10.0.1.20. So let's call it 1.20. And the CSR interface is gigabit 2. It is using the 1.175 IP address. So the web server need to talk to the CSR and talk to the on-premise environment. And on the CSR, we also create a loopback IP address. So it's using 2.2.2.2 just to identify the CSR identity, because in LISP, we'll use this IP address as the RLOC of the CSR IP address. And on the ASR side, you have a loopback 1.1.1.1, and you have three interfaces. Gigabit 1 facing the internet, we don't have to worry about that. Gigabit 2 facing the LISP subnet, which is 1.119. And on the database server, it's 1.100. Okay, so as you can see, this database server and the web server, they share the same subnet, which is 10.0.1.0/24. And then you also have a management subnet, which is 20.0.2.100 for the management server. So we'll be testing from database server talking to the web server, make sure the same subnet can talk to each other even they are dispersed, spread it across public cloud and data center. And we'll also demonstrate how the management server can talk to a web server or database server, even if they are in a different location. Okay, so let's take a look at the configuration first. So there are IPsec configuration, which I didn't include in this walkthrough, but you can find the full configurations used in this demo in my GitHub link. It has two files, ASR for the data center and CSR for the AWS. I only listed the important or critical configuration I want you to kind of remember here. So there's a loopback, as mentioned, ASR 1.1, loopback on CSR 2.2. And you also see there's gigabit 2. This is the LAN-facing interface I'm talking about. So you need to configure this mobility subnet configuration. And the subnet 1 is defined in the later router LISP section. But you need to enable this configuration. And this is more like a dynamic host detection and the gigabit interface, which is LAN-facing. And looking at router LISP, you need to configure locator site. So on the left side, you configure as data center. On the right side, you configure as AWS. And you need to configure your locator ID. So that's going to be used by LISP to know, okay, based on the host I detect, I need to send a packet to which locator or which remote router. So I use loopback IP address for the locator. That's why you see 1.1.1 on the left side and the 2.2.2 on the cloud side. And then you need to configure the persona of the router itself. So the ASR, because it's running as a proxy XTR, so XTR means ETR plus ITR. So you need to configure the proxy part. And you need to configure it use the map resolver as itself, and also the map server, which is defined in the end of the configuration section. On the right side, on the CSR side, on the cloud, it's just using XTR, so you need to configure the ITR and the ETR, and also it needs to use the map resolver and the map server, which is configured on the ASR. So you just need to point the map server and resolver to the ASR. And then you have your instance ID. So that's where you define the stretched subnet. So you define subnet 1, and define the subnet setter block. So you can see those configurations are pretty identical. Just the locator site is a difference. And then you enable the service IP, that's the same. And the other difference on the data center side, you need to configure the site because it will be used as the map server and map resolver. So every LISP router will come to this site to register themselves, and it will send the host they detect. It's more like a controller or central database if you think that way. So the configuration looks pretty straightforward. So as you follow the configuration, you'll be able to make it work. So let's take a look at my environment. So I have on-premise setup here. So I have my CSR data center, I have my database server, I have my management server. Okay, and let me just open up my database server here so we can log in. Okay, so it logged in. Let me stop the ping. And then I have my CSR running in the AWS environment, which is here. So I have 3 servers. Actually, this is a jump server I didn't use in this environment, but I have a CSR running in the cloud. I have this VM. As you can see, this is 1.20 IP address. So let's log into the CSR. This is my CSR, this is my ASR on the data center. And this is my CSR sit on the public cloud. Okay. So the configuration is already configured. If you want to find the full configuration, which I saved here, this is the full configuration, which includes IPsec as well, but also the same configuration you can see with the Gigabit 2 or even with the router LISP configuration. So let's do a couple configuration, check a couple configuration. Let's see, the tunnel is up. I'm using the tunnel 0. So on the other side, we also have this tunnel 0. Yep. So this is up. And let's initiate a ping from my on-premise database server to my. Let's check my database server IP address. It's 1.100. So now I need to ping 1.20, which sits on the cloud. So let's ping 10.0.1.20. Okay, it's working, right? So it's going through my data center ASR, going into the IPsec tunnel, lands on the CSR IPsec tunnel, and then goes to the VM. So let's check. We can keep the ping going, and then let's check some configuration on the CSR on both sides. And I also listed the configuration I'm going to use in the presentation here. So those are the verification steps you can use. So show IP LISP database. This is to know what is the host I detected on my side. So on the data center side, I detected 1.100. And then on my AWS side, show IP LISP database. What are these hosts I detect? I detect 1.20. Okay, and I use my locator. This is what I mentioned about the identifier. 2.2.2. That's on the AWS. And on this side, I'm using 1.1.1. So this is something you detect here. And let's see what are the other command we can do is show IP LISP map cache. This is verify the host to RLOC, the remote locator mapping, which is more like what are the hosts I learned from the remote side. If I do a show IP LISP map cache, I can see I learned about 120 from 2.2.2. Okay, and I assume on the other side I will be able to learn about show IP LISP map cache 1.100, right? From 1.1.1. So as you can see, you use show IP LISP database to know 1.20 is on the cloud side, which is connected to the CSR in AWS, and you use show IP Lisp map cache to know the remote host I learned from Lisp control plane. Those are the two critical configurations you need to verify. And there's another one called show IP Lisp dynamic detail. Let me just copy this one to verify your local dynamic EID host detection. So let's see what from data center side. It gives you more detailed information about this 1.100 host you detected. And on this side, it takes you more detail about 1.20 you detected. So it's pretty straightforward to do the show command. And there's another command I want you to know is show Lisp site. This is to verify your EID registration on the MIP resolver and MIP server. And this is only available, well, you only need to do this on ASR data center because you only do this on the MIP resolver and MIP resolver, which is the ASR. So let's go this side, and this will tell you, oh, sorry, let me just copy this, show Lisp site. Actually, you see this gives you a central database view of all the hosts, all the Lisp router has detected in the network. So 1.1.1 is myself, so I detect 1.100. And on the Lisp side, I detect 1.20, and there's another one at 1.1. So this gives you a central view of a central database of what hosts, where the host sits. And this will help if you have a CSR in AWS VPC1. If you have another CSR in VPC2, and you want them to have the same subnet, now you will be able to see another line about another host that sits on a different CSR RLOC, right? So this is pretty straightforward demo. And there's another command I would like to show you, which is you can know what is the real data path, show IP staff. Let's put 10.1.1, 10.0.1.100, because this is the one that sits on AWS. And let's see what is the staff table for this IP address. Oh, sorry, this is on the local side. We need to check the 20. As you can see, the next hop is 2.2.2, which is the CSR RLOC identifier, and the next is using a Lisp tunnel. Okay. So I also build up the 2.2.2 and 1.1.1 connectivity using OSPF, so which is also part of the configuration I put on the GitHub. So you can apply the whole configuration. You just need to change the tunnel destination to your environment destination. So that's the only thing you need to do. I think we also talk about, I have a management server which sits on a different subnet. And let's see if the management server can talk to both of the database and the web server, even if they are deployed in different places. So this is my management server access. Let's see what is the IP address. I'm using 20.0.2.100. So let's see if it can talk to the database server first, which is in the same data center. Let's check. I think it's okay. 100. Yep. So it can talk to the database because they are connected to the same ASR. Let's see if it can talk to the web server I moved to the public cloud, which will be 1.20. Yep, it can also talk to that server. As you can see, the latency is also different. If I'm talking to a local server, it's like a sub-millisecond. But if I'm talking to a server that sits on AWS, it's over like 3 milliseconds. So which means in our case, we have verified that by using Lisp, you can move the server to the cloud without changing the IP address, and it can still talk into the other server on the data center, and they share the same subnet. So you can stretch your subnet from your data center to the AWS. And also the non-Lisp subnet, if they are running a different subnet can also talk to both of the servers. We also have a deployment guide here available, so you can just went through the deployment guide as well, and the configuration example, which is I use in this demo, I put on the GitHub link. So what's next? As I mentioned, we supported AWS starting from 16.9.1 and later release, and Azure and Google Cloud Platform is in work in progress. But as you remember, in order for the CSR to get the IP address of the request, you need to configure the secondary IP address on the interface. So when I say we are working on Azure and Google, is we are more like validating if that they support the secondary IP address. So till now, seems Azure supports it, but Google Cloud Platform doesn't support a secondary IP yet. And I think they are working on to support that. So once they have the full support, we'll be able to support the layer 2 subnet stretch into the public cloud. All right, thanks for watching. And you can leave